Now we'll see some word problems where the information is given in statements and we convert into the mathematical form where the word problems are connected with linear equations in two variables x and y. So let's start with this example problem, which is quite interesting, and this is one of the very ancient problem in Hindu mathematics, where the Vedic mathematics, where this was really a very interesting concept utilized out there. Now, for example, here the question says, in a garden there are some bees and flowers. If one bee sits on each flower, then one bee is left over, and if two bees sit on each flower, then one flower is left over. The question here says, find the number of bees and number of flowers. Now this question has only two basic conditions given out here. The condition 1 being that one bee sits on each flower, then one bee is left, and two bees sit on each flower, then there is one flower left. And using these two conditions of the real life situation, I need to find the number of bees and number of flowers which are existing in the garden. It is quite interesting that we use mathematics to solve this puzzle. So therefore, let's see how we can connect this problem with linear equations in two variables x and y, a real life example of linear equations. So for example, I don't know the number of bees and number of flowers, so I assume them as x and y because they are unknowns which I need to find. Therefore, let number of bees in the garden be equal to some x, an unknown, and the number of flowers in the garden be y. In the garden is some y. So using these concepts of x bees and y flowers, let's see how my condition turns into a mathematical equation. Now if I read this statement very carefully, if one bee sits on each flower, then one bee is left. Therefore, say for example, I assume 5 flowers, then how many bees would be there for those 5 flowers? Because the statement says that if one bee sits on each flower, then there's one bee left. Therefore, if I have 5 flowers, there are 6 bees. Because 5 of them are already occupied on each of the flower, then there's one left. That means 5 plus 1. Similarly, if there are 10 bees, then I think if there are 10 flowers, then definitely there are 11 bees. So every time I see that the number of bees is one more than number of flowers, which says that if there are x bees, then I have the relation that x equals y plus 1. Because the number of bees is always one more than the number of flowers, as can be seen with this condition. So this is strictly because of x bees, I have one additional bee compared to the number of flowers, which is already 1, y. Therefore, I have the equation x equals y plus 1. That implies I can write this as x minus y equal to 1, or x minus y minus 1 equals 0, which is equation 1. Is the first condition I have utilized here. Now, as I see the next statement, let's see how the next statement converts to the mathematical equation. Here, I have the condition stating that if 2 bees sit on each flower, then one flower will be left, which makes me understand that there are 2 bees sitting on each flower, but here one flower will be left over. That means there's no bee sitting there. So each of x is 2y, 2 times of this. Because if I observe the statement very carefully, if 2 bees are sitting on each flower implies each bee is sitting on flower twice of y, but I have one flower which is left. That means I have that subtracted. If I take the number of bees is 2 times of y minus 1, with one of the flower left over, which is subtracted as 1 from this. And then finally I get here, continued with this, 2y minus 2, which on further simplification gives me x minus 2y equals minus x minus 2y plus 2 equals 0, which is equation 2. Now the question here is how to solve these two equations. We have already discussed on solving of these two equations using the simultaneous elimination method or graphical method, where we sketch the line 1 and line 2, and wherever we get the point of intersection of two lines is nothing but the solution of the two lines, which is x and y, is how we understand. So let's see how we can solve this equation 1 and 2 by elimination method. So let's see the elimination method, where I take the two lines. I take the line 1 below the line 2, which is given to be x minus y minus 1 equals 0, which is equation 1, and I subtract the two equations so that the signs change, and then this gets cancelled and I get minus 2y plus y is minus y, 2 plus 1 is 3, which is equal to 0, and therefore I get this as y equals 3. So indirectly I identify that the number of flowers are 3. There are 3 flowers in the garden. And similarly, when I substitute this y in one of the equation 1, say I substitute y equal to 3 in equation 1, then I get the value of x. As I get this, x minus 3 minus 1 equals 0, which is x minus 4 equals 0, minus 3 minus 1, and this is x equal to 4. Therefore, I get the conclusion that there are 4 bees and 3 flowers in the garden, which satisfy the two conditions, the condition 1 and the condition 2 given in the statement. The condition 1 and the condition 2 given in the statement. Therefore, number of bees in the garden is 4, and number of flowers in the garden is 3, which solve the given problem. Is how we understand the linear equations in real life situations. So any problem given in the word form, we just examine that carefully, then convert that into a linear form, and then simplify and find the solutions of the two lines either by the algebraic approach or the graphical method, which we have already discussed in the previous sessions, and then finally those values of x and y will conclude the answers.